let us discuss regarding ozone depletion. So all of you know ozone is a triatomic gas and it is formed in the upper as well as in the lower atmosphere. We are mainly here to discuss today regarding the good ozone, the one that is formed in the upper atmosphere, to be more specific in the stratosphere. So this ozone that is formed in the stratosphere, it is going to form a shield of ozone that will be saving or protecting the earth from harmful UV radiation. Okay, this good ozone will absorb all the UV radiation and will not allow it to reach out to us, and because of that will be protected from various types of harmful effects of the UV radiation. Alright, so let us start. See, ozone or O3 is an independently formed gas in the lower or upper atmosphere. In the lower atmosphere, the one that's formed is called bad ozone, whereas in the upper atmosphere we call it good ozone. Okay. Now, types of ozone. Bad ozone. It forms in the lower atmosphere and harms plants and animals. Whereas good ozone, it is formed in the upper atmosphere, that is stratosphere, and act as a shield absorbing UV radiation from the sun. UV is highly injurious to living organisms as the DNA and protein of living organisms absorbs UV and breaks its chemical bonds, leading to various types of mutations. Alright. Now, the thickness of ozone in a column of air is measured in terms of Dapson unit, where 1 Dapson unit is equal to 1 parts per billion. Ozone is continuously formed by the action of UV on molecular oxygen and also degraded into molecular oxygen in the stratosphere. Disruption of this balance is caused by enhancement of ozone degradation by CFC. CFC or chlorofluorocarbons are ozone depleting substances, ODS. So as more and more of CFCs will be released, that much of chances of ozone depletion would be increased in our environment. Okay, and if ozone is depleted, of course you know that harmful UV radiations will be able to reach out to us, causing various types of diseases or various types of mutations. Alright, now ozone depletion. CFCs are widely used as coolants in the refrigerators, and when discharged in the lower atmosphere, it would directly move upwards and reach the stratosphere. Once it reaches the stratosphere, it will be the UV reacts with them. Once it reaches the stratosphere, UV will react with them, releasing chlorine atoms. Okay. Now, once chlorine is released, the chlorine react with the ozone, converting it into oxygen. So, O3 will be converted to O2 by the chlorine that is being released by the CFC. And not only that, an active chlorine can destroy 5,000 molecules of ozone in 1 month and 1 lakh of ozone during its entire stay in the atmosphere. Basically, the chlorine that is being released will be acting as a catalyst in this reaction. Because it is just used as a catalyst, it is not going to get over or it will not be used up in the reaction. Rather, it will stay in the atmosphere for a very long time, and as many as 1 lakh ozone can be depleted by a single chlorine during its entire stay in the atmosphere. Alright, the reaction being as such, the chlorofluorocarbons will be first by the action of UV converted to chlorine, and this chlorine on its release will be converting the ozone into oxygen, and the process will keep on getting repeated throughout, where the chlorine is just being used as a catalyst. Due to that, a continuous process will be initiated where the O3 will be continuously being converted to O2. The ozone will be continuously converted to oxygen. That's how ozone depletion will be occurring. Alright. Now, ozone depletion may be widely occurring in the stratosphere, but it is particularly marked over Antarctic region each year between late August and early October. This has resulted in the formation of a large area of thinned ozone layer, which is commonly known as ozone hole. Alright. Now, for this discovery, Sherwood Rowland and Mario Molino, along with Paul Crusten, were honored with Nobel Prize for Chemistry in 1995 for discoveries related to ozone depletion and mostly ozone hole. Alright? Now, effects of ozone depletion. Of course, if ozone is depleted, UV will be able to reach out to us, leading to various forms of skin cancer. Why skin cancer? Mostly because UV only can penetrate up till our skin. It does not penetrate beyond the skin. That's why UV related mutations are mostly confined to the skin. So UV, if ozone is not there, UV reaches out to us, it will mostly be affecting our skin or our eyes. Alright. Now, UV radiations of wavelength shorter than UVB are almost completely absorbed by Earth's atmosphere. That's why UVB will be mostly reaching out to us and causing harm. So UVB damages the DNA and causes various mutations. It results in aging and various forms of skin cancers. Also, it causes inflammation of the cornea called snow blindness, cataract, etc. Alright, so skin and eyes are mostly affected. Fine. Now, International Initiative for Ozone Depletion. An international treaty known as Montreal Protocol, it's very important for your exam. Montreal Protocol was signed at Montreal, Canada in 1987, effective in 1989 to control the emission of ozone depleting substances, ODS, mostly CFC. Alright, so nowadays instead of CFCs, HFCs, hydrofluorocarbons, are being used as coolants so that they, CFCs' harmful effects can be reduced. So that's all regarding this topic as well. In the next class, we'll be starting with the last topic of this chapter, that is deforestation. Thank you.